We've shown you one way, probably the easiest way, to set up a login node for your PCS cluster, and that is to use a dedicated compute node group with a special static configuration. Now, if you want your entire cluster managed by PCS, that's a perfectly fine solution. But you can use almost any Linux server or instance to access a PCS cluster, and I'm going to show you exactly how to do that. Well, first, why might we want to do this? Let's see. So for one, you can attach standalone visualization nodes to your cluster. For instance, let's see, VDI workstations provided by Research and Engineering Studio. Another thing you might want to do is provide access to the shared file systems on the cluster, even if it's offline. You could use this as part of a maintenance or cost control strategy. Another use case is just to assign a static IP address, or even set up a custom DNS name on your login nodes. And that can make it easier for your users to remember how to access the system. Speaking of making things better for users, if you've got a swarm of busy little bees who tend to overload the login nodes, you could, although we're not going to show you how to do it here, wire up an auto-scaling group to add more login nodes when things get spicy. Finally, you can build dedicated login nodes to support workflow managers like Luigi, Nextflow, Cromwell, and so on. Since some of these have their own web applications or REST APIs, your login nodes there don't even have to offer SSH. So, what's involved in making a standalone login node? So first, there needs to be a network path between your login node and the cluster's Slurm controller. Now, if you're launching in the same VPC as your cluster, there's probably already a route between the new instance and the cluster. If you're launching in another VPC, or you're connecting from outside AWS, then you need to set up the appropriate routing. Now, one thing you can't do is just give your cluster a public IP address. PCS doesn't support that, and I'm not sure it's great security. Next, while we're talking about network connectivity, when you set up your cluster, you provide a security group for the controller, and that controls connections in and out of the controller. Now, there's a good chance that you set that security group up to allow only access to hosts that are within that security group. This is what's known as a self-referencing security group. Now, again, that's probably fine if you're in the same VPC, but if you want to connect to the controller from outside the VPC, you might need to add some incoming rules to your cluster security group. So what else? On the instance, you need to install the specific Slurm version used by PCS in your cluster. Luckily, we provide an installer to help you do just that. Now, once that software is installed, you need to configure a service that comes with Slurm called sacd. To do that, you need the address of the cluster controller, and you need the cluster secret. Well, how do I get those, you ask? Well, you ask the cluster for them using AWS APIs, and I'll show you the details about that when we build our login node. So, once you've configured sacd, you should be able to connect to Slurm running on your cluster. Totally easy peasy. So let's see this in action. What we're going to do next is I'm going to build a login node manually so that you can see how each step works. But I can guarantee you that this whole process is 100% designed so that you can automate it. And I'll give you some tools to help you do that as well. So we're in the AWS console where we're going to launch an EC2 instance, then wire it up so that it can talk to the demo cluster that we built in a previous video. So first, let's start by checking out that cluster. So we'll go to the PCS console. Here's our list of clusters. The one we're going to connect to is called Get Started. A couple of things you need to remember. You need to know the name of the cluster or its ID. You can use these interchangeably when working with PCS. You need to know the VPC that the cluster was launched in. You need to know the subnet that it was launched in. And you need to know the security group that has been attached to the PCS controller. You don't have to remember these, but you do have to be aware of them for future work downstream. Okay, so let's go launch that instance. So here we are. Let's go to the EC2 console and launch an instance. Let's call it Bring Your Own Login. And we're going to use Amazon Linux 2. Why are we picking Amazon Linux 2? So the operating system that you choose has to be supported by the PCS Slurm installer that we provide. You actually have a choice of Red Hat 9, Rocky 9, or Ubuntu 22. I'm picking Amazon Linux 2 because it's the same operating system as my cluster. Let's pick, so now that we've chosen the operating system, let's go pick an instance type. C6A, 8 extra large. It's got a lot of CPUs and memory. Great for a login node. Pick a key pair. And now we get to network settings. Now, some of this is kind of important. So for network settings, especially in the EC2 console, the default behavior is to launch your instances in the default VPC, but we don't want to do that. we want to launch in the same VPC where our cluster lives. So we need to change this. So we'll go from here and we'll pick the HPC, VPC, and now we need to pick our subnet. So we want a public subnet so that we can get a public IP address, but we don't want just any public subnet. If you'll remember from the demo cluster video, we launched everything in US East 2B. So we need to find the public subnet that's in US East 2B. So we can scroll down and find that. It looks like that is public subnet A. Okay, that means we can auto-assign a public IP address. We want that. Now we have to assign security groups to the instance when it launches. And we're going to assign 3 security groups. 1 is mandatory, 2 are optional. So the one that's mandatory is the cluster security group. So if you'll recall, when we created our demonstration cluster, and usually when you create any cluster, you create a cluster security group and you assign it to the cluster controller. And that controls what IP addresses are allowed to connect to and be connected from the Slurm controller. Since we're building an instance that wants to talk to the Slurm controller, it needs to be in this security group. So what we're going to do is we're going to not create a security group. We're going to select security groups. Here's the cluster security group from our Get Started cluster. And then we're going to add 2 more security groups. 1 to allow inbound SSH to the instance, and the other, we're going to add the default security group for the VPC so that the instance can talk to the FSX for Lustre file system that's attached to the cluster. So inbound and 1 more, the default. If you're wondering where these security groups came from, if you're wondering where these security groups came from, remember that we created these as part of the workflow for creating that demonstration cluster. Okay, so we're ready to move on. Let's configure storage. Let's make the base root file system a little bit bigger, 50 gigs, a little bit faster storage. And now under advanced details, I'm going to do something. You don't have to do this, but I'm going to pick an instance profile that allows me to connect to the instance using SSM. And that's because I like to use SSM wherever I can rather than SSH, because I can connect to my instance right from the browser. Okay, so here we go. Let's launch the instance. And now it will be a couple of minutes before that instance is ready. But let's go ahead and just watch for it. We'll wait for it to finish initializing, and then we can connect to it. Okay, it's been about a minute and a half, and our instance is now up. It's running. It's passed its status check, so we can go ahead and log in using SSM. So I can just select the instance and connect. It will go to Session Manager because that's configured. Let's start off by becoming root. And we need this because we're going to install some stuff and we're going to do a lot of different configurations, and so it's just easier to do this as root. So first, let's mount our FSX for Lustre file system. So we need to install the Lustre driver, and when that's done, we'll make our shared directory, and then we're going to mount the shared directory. Make sure it's writable, and now let's check and see if that mount actually happened with disk free. And there it is, /shared. It's a 1.2 terabyte file system, and you can see it's a network mount because it's coming in from an IP address and a mount name. So now we're ready to go. There's probably a bunch of stuff on that shared directory that you'll remember from the demonstration cluster. There's the outputs of our multi and single node jobs. So just to prove that that's the file system we're connecting to. Okay, so what we're going to do now is we're going to install Slurm, but we're going to use the PCS installer provided by AWS. So we download the Slurm installer as per the PCS user guide. Let's untar it, cd into the installer directory, and run the installer. This will take a couple of minutes because right now we're actually compiling Slurm and its dependencies from source, but really only like a couple of minutes. Meanwhile, you're ascending to the pantheon of HPC gods and goddesses because you're compiling Slurm from source. So feel good about that for yourself. Almost done. Right now it's compiling PMix, which is important for MPI. And now we're actually checking out and compiling Slurm from source. Oh, snore. Do you remember when you thought this part was fun? Slurm, okay, so Slurm has now been compiled and installed. It's actually at AWS PCS scheduler Slurm 2311. Since this is not a standard path, we need to add the Slurm commands to the default path. Let's add these commands to the default path for all users. So to do that, we'll just write to etc profile D. So that just extends the path to include opt AWS PCS scheduler slurm 2311/ben. Okay, so now it's time to configure SACD, which is the authentication daemon that is bundled with Slurm. So to do this, we need two pieces of information. First, we need the IP address and the port for the Slurm controller, and we need the Slurm secret, which is basically the authentication token that allows a client to connect to the Slurm controller. So we can't access either of these from within our instance, at least not the way that it's configured now. So what we're going to do is we're just going to go to a terminal. I'm using a standalone terminal in my desktop environment, but just for your reference, you should be able to do this in a Cloud Shell in the AWS console just as well. Here we are in our terminal. We're going to use PCS get cluster to find the IP address and the location of the cluster secret. So we'll do AWS PCS get cluster, and our cluster ID is get started. We could have also used the alphanumeric ID for the cluster, but I like to use the name when I can. And here's our output. So let's walk through this. Two pieces of information you need to know. So the Slurm secret is under Slurm configuration, auth key, secret ARN. So that's this. And the Slurm controller endpoint is here under endpoints. The type is Slurm control D. The IP address is this. The port is this. Okay, so copy these down, note these somewhere, clipboard, a document, whatever. We're going to go back into the instance and insert this information into the instance and continue configuring SACD. Here we are, we're back in our instance. Cluster address is just the combination of IP address and port. Let's go back to our console and actually fetch the secret. So let's fetch the cluster secret from AWS Secrets Manager. So here in the output from get cluster, then Slurm configuration, auth key, secret ARN. This is the location for the secret. You can't get the secret directly from an API call against PCS. What you do instead is you use Secret Manager and get secret value in order to retrieve it. So that's exactly what we're going to do. So we need to note that ARN, blah, 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 blah. We clear the screen so it's a little bit more obvious. Here's our command. AWS Secrets Manager, get secret value. We're going to query for the secret string. We want text output, and the secret ID is that ARN. I want you to note that I have single quoted it. Why did I need to do that? Well, there is an exclamation point in this ARN, and that's because this is a service managed secret. If you don't single quote the ARN, it will make your terminal sad. Okay, so here's this big string of text. This is the cluster secret. It is base 64 encoded. I'll show you what the implication of that is in just a second. Right now, we're just going to copy and paste it out of our terminal. And we're going to go back into the environment that we're configuring, and we're going to memoize this as an environment variable, key. Okay, so now we're done with the terminal. and we're going to go back in the instance. So the first thing we're going to do is we're going to write this key out to a file, but we're not going to write it in this form. We have to decode it. Before we decode it, we have to have a place for it. So the location for it is etc slurm. So we're going to make an etc slurm directory. Let's make sure the ownership is the Slurm user and group. And then we're going to write this key to a file called slurm.key inside this directory, but we're going to decode it from base 64. So here's what the command for that looks like. We're going to echo key, we're going to pipe it to base 64 decode, and we're going to take the address from, we're going to take the output from that, and we're going to stick it in slurm.key. Okay, so if you just, you'll see this is crazy binary. It's not at all interesting to you. So we need to lock this key down so that only the Slurm user can find it. It's important to keep tight control over your cluster key, especially if this is a multi-user, node. And the reason is anybody who can get a hold of this key can impersonate other users on the cluster. That's probably not something you want to enable. So what we do is we change the ownership and permissions on the Slurm key so that only the Slurm user and group can access it. Now you can see that only the owner, Slurm, can read and write this Slurm key. So we're going to set up the sacd service. This is something that runs in the background. So we're going to do this with systemd. We're using systemd because it's the default these days, but really, if you've got a preference for another service management system, that should work, but the implementation of that is totally up to you. Okay, so first we need to set a sysconfig variable. To do that, we're going to use that first variable that we memoized that includes the cluster IP and port. So this just puts sacd options as an environment variable. Out to that, if we look and see the contents of this, there we go. That's that IP and port. Okay, so now we're going to write out a systemd service file. I don't expect that you copy and paste this from the video stream. There's a template for this in the assets directory of the HPC recipe that's associated with this video. Here we go. So you can see I'm writing to etc systemd system. I'm writing a service name named sacd. This is a bunch of stuff. You shouldn't really fuss around with this. Here, note the path to sacd note the path to sacd in the installed Slurm directory. It gets configured with the sacd options environment variable that we set in the previous step, but this isn't quite enough to get the service up and running. So we've written out the service file. We need to set its ownership. It needs to be owned by root and have specific permissions. And now we can enable the service. So we reload the daemon for system control, and we enable sacd. And now let's go ahead and start the service. Okay, and we can actually wait a second or two, and then we can check the status of the service. The upside here is you're going to learn very quickly whether all of this configuration worked correctly, because the sacd service won't start up correctly unless it can talk to your Slurm controller. Look, active, running, green text. Green text is good, red text is bad. So theoretically, this should work now, and we should be able to run Slurm client commands. So let's go ahead and test this out. sinfo, sq, scontrol, etc., etc. Okay, so let's start with sinfo. Oh, wait. What's happened here is we set the Slurm binary path in the default path, but we haven't logged out and logged back in again. So let's log out of root. Let's become root again. sinfo. All right. Let's try sq. There's probably nothing running on this cluster. It's not particularly a busy cluster, but nevertheless, you can run sq. If we wanted to, we could write and submit a job. We can do scontrol. Anything that your user on this instance is authorized to do, you can run any command that you want to. Okay, so that was just about it. So I have shown you how to build a standalone login node for PCS. I recommend that you check out the relevant section in the PCS user guide. And then I recommend that you try this out manually before you try to automate it. So when you're ready to start automating, check out the Bring Your Own Login Node HPC recipe that's associated with this video. If it doesn't when the video airs, very soon it will include a CloudFormation template that puts everything together for you. If you're interested in building out a dedicated Viz node, something with a GPU with DCV installed on it, check out the CFD cluster recipe. It includes a CloudFormation template to launch a powerful DCV-enabled instance that you should be able to adapt into a login node with just a couple of tweaks.